Hello, my name is Igor, and this is another Ender3 V2 upgrade video when I'm upgrading it to the dual Z-axis, but with the version with the pulley and the timing belt system and one stepper motor. And this packaging is sent to me by Banggood for a review. Don't be confused, I already did the dual Z-axis upgrade with the two stepper motors. I will get to that later. But first let's see the reason for this upgrade. By default, Ender3 is supported only on one side with this lead screw, and we all know that it is much easier to hold something by supporting it from two sides compared by supporting on one side, even if the other side is partly supported by those wheels. But I could measure the playing of the 0.2 millimeters on the other side, but that's not that big problem. Because the gravity is holding down in one position. The problem may appear if you want to print on higher speeds or you want to add any additional weight to the hotend. For example, a direct drive extruder is a typical upgrade which requires a dual Z-axis upgrade, because the stepper motor will be moved directly on the hotend with its own weight. Now, a few weeks ago I did this upgrade with the version with two stepper motors. And yes, it is a little bit harder, the assembling, especially the wiring part. It took me exactly the same time, almost like the mechanical upgrade. And I got several messages that, okay, very nice upgrade, but the average users are a little bit afraid to mess with electronics. Nothing complicated, only they have to replace this wire with the provided wire, which splits to two. But yes, you have to open the bottom of the printer to see the motherboard cover and to replace this cable and to find the pad to the other side. And yes, that looks maybe scary to average users. Well, good news is that this upgrade is only a mechanical, so there is no messing with the electronics. There is one additional problem with this version with two stepper motors. It is important to know about this problem, and then you can prevent any issues. When the stepper motors are powered, they move in synchron perfectly. Even better like this with the timing belt system. But the problem may appear when the stepper motors are not powered. Theoretically, these two lead screws could move independently from each other. Theoretically, but you will see I will now rotate only one and the other is rotating too, because these wheels are trying to hold their position. But even then, if this is, for example, hold, I can move this one. So we know the problem, how to prevent it. Never move the Z-axis with your hands. Never do this, and now I have to level the bed again. Or don't press the X extrusion, X gently, because theoretically you can move the other side and it will be out of the synchronization. Now this is less sensitive to this because the friction mostly holds in its place. So to summarize, this system works really perfect when the motors are powered. When they're not powered, don't touch the Z-axis lead screws and it will work perfectly. At the beginning, try to check the bed leveling a little bit more often, or this upgrade is very useful in this case. It is BL Touch auto leveling sensor. It is not mounted yet, it will be in near future. And now I will remove this dual Z-axis with this stepper motor, and then I will mount the new one and to see how it performs. But first let's see what's in the packaging. Very interesting that this package didn't come in the box, only in additional black plastic bag. So if you receive this, always check that these lead screws are not damaged and they are straight. So here we have some pulleys and bolts, the passive block, ball bearings. They will hold the top of these lead screws, the timing belt, and this is tensioner, and that's it. No electronics. Of course, I have to mount the back, so I have to remove this second Z-axis and stepper motor. And it's finished. Now again it is a single lead screw printer. In first step I will replace the original lead screw with the provided new ones, because these are a little bit longer. Put something below alloy extrusion, so it will hold it in a place when I unscrew this and take out this lead screw. So now the X-axis sits on this box. So on this coupling only the upper bolt is connected with this lead screw. And now I can take it out, and the X-axis is now sitting on this box. The original lead screw is 36.5 centimeters. And the new one 38.1 centimeter. But beside that they should be equal, so here they are side by side. I will just rotate it into place. It has to go completely to the bottom of that step hole inside, and then I can tighten now this bolt. Make sure the lower is also tight, because you don't want these bolts to loose during the printing. Now let's mount the passive block here on this side. For this we will need these longer screws provided in the packaging, and also these ring distancers. Next step is to mount this passive block. So this is the position of the passive block. As you can see, the original bolts are a little bit too short. So that's why we got these longer bolts here, and also additional ring distancer which will go on the other side of the wheel. To remove this bolt I will need an Allen key and 8mm open-end wrench on the other side. And the longer bolts I will mount from the other side. So this is the order, and here goes the passive block. The third wheel is a little bit tricky, but not complicated. So here the bolt is inside this alloy extrusion, and then I can open it with the open-end wrench from the other side. Fortunately, the head of this bolt is in the slot of this alloy extrusion, so I cannot take it out so easily, but I have to remove these two bolts, and then I can move it so I can take it out from the other side. And now I can turn it, this passive block, on the other side, and then I can take it out and replace it. Originally there was a washer even on original bolt, so use that washer with the new longer bolt. And place back these smaller bolts which we removed a few minutes ago. And remember these two bolts, because with these two bolts you can do some small adjustment to level to make this alloy extrusion horizontal. And now let's place these longer bolts back. Ring, wheel, ring. And on the third one we have this nut, eccentric nut, and there is a part which stands out a little bit that goes into this hole here, so in this position. And now the passive block. These screw nuts are from the stock Ender3, so we have to reuse them. and tie them. I'm using the Allen key from the other side and open-end wrench from this side. The last one may be tricky because you have to find the hole through the hollow extrusion to tie the head. Now it's rotating freely, so I have to tighten this adjusting wheel. This is the open-end wrench provided by Ender3 printer, and I'm turning this adjustable X-ring nut until it's not tight. And I cannot turn it with my hand anymore. And at this step you want to check does it move freely, so rotate the Z-axis with your hand and it should go completely up and down without any problem. The next step, I want to install this top holder for the screw lids. We have the bolts and the T-nuts here inside. And this is my method, so I'm lowering the Z-axis. And now I can bend a little bit this lid screw, but without damaging, just a little bit, because I will insert here the bolts and the T-nuts, and I want to place them in this slot. I'm inserting the bolts and I will place the T-nuts, maybe 2 or 3 rotations. Ball bearing goes up. And T-nuts should rotate 90 degrees so they are locked in the position. Maybe I have to adjust this a little bit, so I will not tie completely yet. So very small adjustment, you can do it now, so make sure that this lid screw is parallel with this hollow extrusion. And you can check now, rotating into position, that everything is okay and rotating smoothly. Pay attention if you have some filament guide or maybe where is the top position of this rotating knob. I will see digitally later what is the upper position. Maybe it will be reduced a little bit, I'm not sure. Now let's mount the pulley. First make sure that you unscrew these set screws so they are not inside the hole. And then it should sit down to this ball bearing and then tighten the set screw. Theoretically, this pulley should sit only on the inner ring of the ball bearing, so I don't know, I would use some washer there, but I don't have the so small washer right now with the inner diameter of 8 mm, so I hope it will just do the job as it is now. And now let's mount the other side. And approximately it should stand out similar like on the other side. So this should be tight, but don't forget these are very small set screws, so don't over tighten it, don't damage the set screw. And actually, probably I will here do some final adjustments later when the timing belt is also on it. Now let's see the timing belt. So it goes inside and make sure that it is straight. Oh, it's too small. 616. Okay, let's do some calculation. Distance between two axes, 288. Diameter of the pulley, 12 millimeters. 12 multiplied P plus 2 times 288. So the length should be okay. Okay, so different approach. First I will move the Z-axis down. Now I have more length here, so I can bend a little bit this. So I move it to the right side until I place the timing belt on it. And now go back. Okay, it will be good enough. Again, make sure, try to keep this parallel, but final adjustment I will do later. Don't tighten it yet. Now move the Z-axis up. And now do the final adjustment. Probably I have to push it out and then tighten these bolts. One more time, make sure you can easily move up and down. Actually, I can now rotate only the right side. So at the bottom, this lead screw is moving freely right and left a little bit. So that's why it is important to set the correct position of this top holder when the Z-axis is here, because this distance is now given. It is very tight even now. Almost I don't even need this tensioner, but of course I will mount it so you can see how it looks like if you have I don't know, a little bit bigger belt, just in case. Again, I have no other help, only these images on the Banggood here. And then I can place a tension on this direction or on this direction. It's very easy, just place the two T-nuts and tight with these bolts. In this position. Now let's adjust the tension. And it's ready. And of course, first check with my hand, completely up and down. It's a little bit harder to move it or rotate it like it was only with one screw, so there is a little bit more friction and here this tension, but you should move it maybe with one hand completely up and down. Actually, the upper position is more critical. Fine, let's add some lubricant and then I can test it. Before I test it, let's measure again that wobbling, the angle. So I'm holding the right screw lid and try to move the left one. And it's very hard, very minimal movement. I can see a little bit bigger than when the stepper motor was locked on the previous version. But yes, this solution works. And now I can test it. So I will add some lubricant on both sides. Same on the other lead screw. Oh, and I almost forget, I have to check the level of the alloy extrusion. And I will check the leveling not relative to the printing surface, because I'm not sure that it is leveled. But theoretically this should be its position, but it's very hard to check this 90 degrees. Instead I will just check the distance between this horizontal bridge here. Wow, it's almost perfect. I need this side lower, maybe 0.2 millimeters. How to do it? Well, I will release these two set screw and raise the pulley a little bit. If the alignment is very small, in that case it can be done with those two bolts. Let me show you. That one and here this one on the other side. But that's really minimal. So or those or with these set screws on this pulley. So I will try to use this method. So this has to go inside. Because of this tension, it is very hard to move it. Now the two set screws are released, but I will use the screwdriver from the other side. Let me show you. And it's okay now. Both. And I can tighten these set screws and I'm ready. but printer is not ready yet. Perfect. And it will stay like this. I have to level the bed and I'm ready for testing. Prepare, move, Z-axis. So one last time I am testing with my hand. I'm lowering the Z-axis. And now leveling the bed. First I will lower the bed a little bit, so I want to be sure that it will not hit the printing surface when I'm doing the first homing. Automatic home. Okay, it stopped earlier, so now I have to level the bed and ready for printing. Let's check the maximal Z-axis. The Z-axis is now on 223 millimeters, and here the knob now reached this top holder. Of course, if I remove the knob, maybe I will get 20 millimeters more, but it is something you have to keep in mind. It's 240 millimeters now without this knob. And this is the maximum Z-axis now currently, especially for this video. One more time to check the position of the X alloy extrusion. And the other side. Perfect. And let's check this printing. Perfect 90 degrees. And my last thoughts before the conclusions, it looks like that this system works, but as a mechanical engineer I would never design something like this part here, because theoretically nothing prevents this to lift up except the gravity and partly this timing belt. So probably I will add from the other side a ball bearing. Unfortunately this is 6 millimeters, I don't have 8 millimeters. And just I want to show you the concept. So here I will add some kind of ring distancer, because the upper part has to touch only the outer ring, and the inner, it has to be supported from the other side. Well, something like pulleys or maybe with some 3D printed part, but don't forget it has to touch only the inner ring. Until my 8mm ball bearing arrives, I will try to use only this 3D printed part. And the final conclusions, well, this method with the timing belt and pulley also works. And as I expected, there is no big difference in printing quality, but now my printer is ready for the direct drive upgrade, because the stepper motor will be moved to the hot end, adding a lot of weight to this moving part. Which method is better, the dual stepper motor or single stepper motor with the timing belt? According to my measurements, when the stepper motors are powered, in that case the version with dual stepper motor is much more accurate in that synchronizing. But it is more sensitive to human errors. This means you have to be careful when the stepper motors are not powered. In that case, if you accidentally move one lead screw or press the X alloy extrusion, that bed leveling or synchronizing will maybe moved a little bit. This means you have to pay more attention to the bed leveling. Of course, a BL Touch automatic leveling sensor may help in this case. And also one more disadvantage there is that you have to mess a little bit with wiring, because you have to change that wire for the stepper motors. This version with timing belt and pulley is less sensitive to human errors. Once you set it correctly, in that case the two lead screws will be synchronized whenever it is powered or not, because if I rotate any lead screw, the other will always be synchronized thanks to this timing belt. Which one will I use in future? Well, bad news for you that I will probably use the combination of these two, because I got these two systems and I have only one Ender3 V2 3D printer. Anyway, if you decide to buy any of these, I will place an affiliate links down in the description. Affiliate links means it doesn't cost you more, but it will help to me and my channel if you buy through that link. Well, that will be from my side. Thank you for watching and happy printing!